At APEC 2025 in Atlanta, Georgia, Würth Electronics technical marketing professional Jared Burke presented on the confusion of designing transformers. Now, at Würth Electronic, we love transformers and anything to do with power magnetics. In fact, the original Midcom business was actually centered around these components. So, at APEC, Jared wanted to present about not how easy it was to find an off-the-shelf transformer solution, but rather what you have to be on the lookout for when you are forced to design one yourself. You see, the transformer is the heart of any power supply, but off-the-shelf options often fall short in meeting specific electrical, mechanical, or efficiency needs. You're listening to Würth Electronics' What's Up radio podcast, where each week we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Electronic technical specialists who are going to shine a light on some topics like energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Electronics' What's Up podcast. Today's podcast highlights how custom transformers can address these challenges, optimizing performance, saving PCB space, and ensuring a precise fit for unique applications. So today we'll not only address the challenges of meeting those certain specifications for electrical, mechanical, and efficiency needs, we'll also tackle concerns about cost, lead times, and minimum order quantities, showing how custom designs can actually deliver better efficiency, improved performance, and a competitive edge in the market.
My name is Jared Burke, and I've been with Würth Electronics for the past 14 years. And though I recently made the switch to technical marketing, for most of that time I was a custom magnetics design engineer, designing a variety of custom transformers and inductors to the specifications of our customers. Custom. That's a word that can be a bit scary, right? It conjures up images of hefty design fees, long lead times, and huge piece prices. Many designers have had it impressed upon them to only use off-the-shelf or catalog parts in a somewhat misguided attempt to keep their product competitive in the marketplace. I'm going to spend the next 25 minutes or so going through the stereotypes surrounding custom parts, break them down, and distill the truth from the fiction. We're going to tackle the biggest misconceptions one by one, then follow up by discussing where custom parts make the most sense. We'll then finish by examining a case study involving a specific catalog part and investigate its custom alternative. So let's begin to examine the common misconceptions about using custom parts. I'd like to start off by mentioning that your design is probably already using at least one custom part, the PC board. Most designers don't think twice about using a custom PC board and couldn't imagine trying to do a circuit design using a generic one-size-fits-all board. Your circuit would never be optimized, and it may be difficult to even get it to work at all. The magnetics, especially the transformer, are similarly critical to the overall performance and efficiency of your design, yet far too often they get lumped in with commodity items like resistors and capacitors. So why do so many designers insist on trying to shoehorn a catalog transformer into their design? What stops you from using custom magnetics? Many customers assume a custom part will be substantially more expensive than a catalog part. They're also worried about longer lead times, higher minimum order quantities, long development times, and potential tooling costs sometimes associated with custom parts. So why would a designer even consider a custom inductor or transformer? Unlike other passive components, like capacitors and resistors, it's more challenging to make off-the-shelf magnetics fit every application. Magnetics are more complex, with many parameters that affect their performance. These include not only inductance and turns ratio, but also the number of windings, EMI performance, and parasitic parameters. All these need to be properly tuned for the device to function correctly. Additionally, transformers are often the most safety-critical component in your design. All this makes off-the-shelf options a challenge to fit. Another option to consider is that many catalog parts were designed years ago, and neither the manufacturer nor the various customers who use these parts have any drive or desire to change them. While magnetics are a mostly mature product, there are still new materials coming to market that can improve efficiency and cost. Using a custom part is an opportunity to ensure your magnetics are using the most up-to-date materials and processes. Before we examine these perceived barriers to using a custom part, let's take a moment to define what custom really means. Does a custom part mean a complete redesign? Actually, no. In reality, a so-called custom part is anything that deviates from an off-the-shelf part in any way. This could be as simple as an output voltage change or even just a modification to the marking. I've even had custom designs that were identical to the catalog version in both function and construction, with the only difference being the tolerance applied to a mechanical or electrical specification, such as guaranteeing a 5% inductance tolerance on a part where the catalog version has a 10% tolerance. These types of changes are simple enough to allow the custom part to be built on the same manufacturing line as the catalog version, requiring only a simple modification to the setup in most cases. Now, an intermediate custom part may involve changing the safety standard, requiring an increase in creepage and clearance distances. This type of change may require a bobbin with a larger pin spacing, though the rest of the design may remain completely unchanged. Other intermediate customizations include changing of the power level or modifying the on-off time. When many designers think custom, they picture a complex redesign involving a new bobbin and core, both of which could have extensive development time and tooling cost. Now, while this would represent a custom part, it would be a very complex custom design, and such projects are quite rare and reserved only for the most demanding applications. So, here we've examined our first stereotype, showing that most custom magnetics involve only minor changes, making them still similar in construction to their catalog brethren. So let's start with the topic that's on the top of most people's list: cost. Generally speaking, the cost of any electronic component is going to boil down to the material, labor, setup, and profit. Assume for a moment that an electronics component supplier is seeking similar profit margins on both catalog and custom parts, so we can remove that variable from the equation. Material and labor are both proportional to the complexity of the component, regardless if that component is catalog or custom. Though here we do have our first caveat. Generally, component manufacturers will have a preferred materials list, which is based on the catalog product they manufacture, ensuring that materials are common across many different component part numbers. So even the lower running part numbers will benefit from the volume discounts the manufacturer gets on these preferred materials. So what does that mean for custom parts? Well, it's simple. To keep costs low, work with your custom magnetic supplier to develop a custom design that both meets your specification and uses their preferred materials. While this isn't always possible, just having this conversation with them can lead to at least some cost savings. Now, as mentioned earlier, labor costs are proportional to the complexity of the part, but they're also affected by the level of automation available. This is true of setup costs as well. While it's difficult to fully compete with automated production lines running high-volume catalog parts, if your custom part is also high volume, you may be able to get into a similarly automated line. But are all catalog parts high volume and highly automated? Absolutely not. This is actually another common misconception, and it's especially true with transformers. It's true there are some high volume catalog transformers on the market, and it's very difficult to get to that level with a custom part. But due to the tremendous variety of transformers needed on the market, many of the catalog parts are, in fact, not high volume at all. So it may be that the custom part you're dreaming of to make your circuit perfect is very cost competitive with that catalog part that's almost good enough. Lead time is a tricky topic because there's so many factors that affect the time it takes to get materials, manufacture and test the parts, and get them delivered to the customer. It should be mentioned that there's two lead times of concern: lead time for the initial samples during the development phase, and lead time for production parts once the design is approved. While these two lead times can cause different challenges, they're affected by similar factors, so they can be considered together. Factory loading is of course an issue and can have a substantial effect on lead time. However, factory loading is likely to affect both catalog and custom parts equally, so we can remove it from the comparison equation. But again, there's a caveat here. Catalog parts may have already been produced and could be in stock and ready for shipment. I mean, this is one area where it's difficult for a custom part to compare, as they're built to order and are really never in stock. However, this isn't really as big of an advantage as one might think. Recall that earlier we discussed the huge variety of catalog magnetics on the market, and while this is great, it means that at any given time, a significant percentage of them are likely to be out of stock. The distribution arm of the market can sometimes aid us in these cases, but there are no guarantees. Even a distributor or vendor that attempts to stock every single part number all the time may not have the quantity you need. In fact, this is where custom parts can occasionally flip the script. If you put a stocking agreement on a custom part in place with your magnetic supplier, then unlike a catalog part, you'll never have to worry about another customer purchasing those parts out from under you. Here we can see that there's an opportunity to create an even more secure supply chain with a custom part than with a catalog part. Moving on, the single biggest differentiator in lead time between catalog and custom parts is material availability. Recall earlier that we discussed the preferred materials list that most magnetic manufacturers have. Those preferred materials are usually heavily stocked, making it easier to accommodate unexpected spikes in demand for parts, at least anything that uses the preferred material list. Custom magnetics that use non-standard and non-stocked materials, this can add weeks or even months to the delivery date. While this can be somewhat managed during production with forecasting and stocking agreements, it can add significant lead time during the sampling and pre-production phase of the project. Here's a chart showing a recent study of average lead times for custom magnetics. It should be noted that these were averaged. In some cases, individual lead times for non-preferred materials were much longer. The takeaway here is understanding how important it is to work with your magnetic supplier during the design phase to reduce or eliminate the amount of non-preferred materials in your custom transformer. In many cases, there are several materials and suppliers that will perform equally well in your application, but only your magnetic supplier can help you ensure that you choose materials with the best lead times. Now let's discuss MOQ, or minimum order quantity. This is probably the area where concerns about using a custom part are the most justified. However, minimum order quantities for some custom parts may be surprisingly low. As with lead time, the choice of material plays a big role in determining how a magnetic supplier has to set their MOQs. And let's be honest, profit margin will also come into play here, as suppliers will be more likely to accept lower order quantities on higher margin parts. But this can be used to your advantage as well, as it can be another negotiating point to help you get a bid that will work for your project. Price, after all, is only one part of a successful project, though as many of you know, this can be a difficult battle to fight internally between engineering, purchasing, and management. But as I mentioned, material availability looms large here. What's stopping you from being able to order 200 pieces of a custom transformer? Well, in some cases, nothing will stop you, as some suppliers will entertain custom parts even at this volume. But typically, if your 200-piece custom part order is rejected due to low volume, it'll be because your magnetic supplier has a 10,000-piece minimum order quantity from their supplier on that custom core your part uses. So as with keeping lead times short, keeping minimum order quantities low is usually as simple as ensuring your design uses all the preferred materials from your magnetic partner's list. Still, many custom designers are surprised to learn that a wide variety of custom parts are available, even in the quantities of 1,000 per year. So if your project could benefit from a custom part, but you have concerns about lead times and order quantities, I encourage you to have a conversation with your magnetic supplier. If you selected a supplier that makes custom parts a core part of their business model, you'll probably be pleasantly surprised with what they can offer. Some magnetic components are better candidates for custom parts than others. Applications that require a very specific size or electrical specification can often only be met with a custom part. Applications that have stringent or unusual safety requirements also benefit from a custom solution. And while the vast majority of custom magnetic components created are transformers, there is a place for custom inductors, especially for PFC applications. A third area is wireless power coils. If you can make one of the common Qi coils work, you have many off-the-shelf options. However, for anything beyond that, the choices are slim, and a custom solution may be your only option. This includes almost any application that requires a coil smaller than 10 millimeter diameter or larger than 60 millimeter. Now that we've discussed in general the benefits and challenges that come from using custom magnetics, let's move on to the second half of the presentation. In this part, we're going to discuss a specific case study in custom magnetics using a real-world specification and an actual catalog part number. In this example, we have a typical customer looking for a transformer for their offline switch mode power supply using the flyback topology. Their industry requires that the transformer comply with safety standard IEC 61558-2-16. They want to power a 12-volt circuit that will typically draw around 2 amps, but they would also like the option to be able to use it up to 2.6 amps in certain circumstances. The selected switching frequency is 100 kilohertz, and the transformer must not exceed 32 millimeters on any side. The Würth Elektronik website shows transformer 750811630, which was originally designed in 2009 for a power integration reference design. While not designed for the customer's exact specification, it's the closest fit. Let's take a look at the specification sheet here for the catalog part number 750811630. This is an offline flyback transformer that's smaller than 32 millimeters on all sides. Let's take a closer look at the electrical and safety specifications for this catalog part. As we mentioned, it's an offline transformer as indicated by the universal 85 to 265 volt AC input voltage, and it does have a 12 volt 2 amp output. Recall that the 2 amp was the minimum the customer could accept. The 750811630 also has a second output at 5 volts, which was used in the original PI reference design, but is not needed for this customer's application. While the 5 volt output could simply be left unconnected, it does represent something that the customer would be paying for but is not using. This, and the fact that the 12 volt output only meets their 2 amp minimum, makes a custom part worth considering, but as we'll see, there are other items as well. The rated switching frequency for the catalog part is 66 kilohertz instead of the 100 kilohertz that the customer wants to use. While this is something that could likely be worked around, it's yet another item that makes a custom part attractive. Lastly, the catalog part was designed to meet an older version of the safety standard, IEC 61558-2-17, rather than the current -16 version. A check of these two sections shows that they're vastly similar, yet this is an issue that will have to be addressed when the application is submitted for agency approval. At a minimum, this discrepancy will cause some additional paperwork. Alright, let's step through the changes we can make to the catalog part to create a more suitable custom transformer. The easiest is to remove the 5 volt winding, thereby saving the associated material and labor cost. That cost savings is the low-hanging fruit, but removing that winding also frees up valuable winding space that can be used for something else. In this case, we'll use that space for two things: to increase the wire size on the 12 volt output winding in order to accommodate 2.6 amps, and to add a series split to the primary winding. The series split has several benefits, the most significant of which is the reduction in parasitic leakage inductance by 50 to 75%. Additionally, it helps improve reliability by reducing the possible turn-to-turn stress in the primary winding. This diagram shows the original winding configuration for the catalog part, though I did simplify it by not showing the auxiliary winding. As you can see, the entire primary winding is wound first, followed by a layer of tape, and then the entire secondary winding. This diagram shows the modified winding with a series split added to the primary winding. Now we can see that the secondary is sandwiched in between the primary windings. This is the secondary, sandwiched in between the two primaries, two halves of the primary, here and here, separated by tape. So, from this it becomes obvious why the coupling between the windings is improved, thus reducing the leakage inductance. We can also see that there's no longer any way for the high voltage turns on the primary winding to come in contact with the lower voltage turns on the secondary winding, thus improve reliability. So this would be the lower voltage turns and the higher voltage turns, and you can see here that the two windings are separated, and this is where we get a reliability boost. Another area for improvement is to update the design to use the current version of the safety standard, as well as to take advantage of some of the newer, more efficient core materials. Lastly, we'll improve the stranding of the primary winding. What does this mean? Well, for example, instead of using a single 27 gauge conductor for the primary, we'll use two 30 gauge conductors in parallel. This new configuration has the same DC resistance, but has lower AC resistance due to reduction in the skin effect. Alright, well, let's bring back some of those stereotypes we discussed early on in the presentation and see how our new custom part stacks up. First, custom parts are too expensive. In this case, we were able to remove the unneeded 5-volt winding, which actually caused the custom version to be lower cost than the catalog version in quantities of 2,500 pieces or more. Why isn't it lower at all quantities? Well, this is due to the setup costs associated with lower volumes. But in this case, once we get above 2,500 units, the setup cost is more than offset by the lower material and labor costs from the removed winding. So we're going to consider this stereotype busted. The second stereotype was that all custom parts have long lead times. For this custom version, we were able to use all preferred materials, so the only real difference in lead time is that the catalog part may have stock somewhere for immediate shipment, whereas the custom part will not. So we'll call this one partially busted. The third stereotype is that custom parts will have high minimum order quantities. But again, we see here that because we were able to use the preferred material list and the standard manufacturing process, the minimum order quantity could be kept to a nice low 200 pieces, effectively busting this stereotype. Fourth is that custom parts have a significant development time. This version had a fairly quick 2-week time to delivery of the initial samples, but that's still time that wouldn't be needed if you were going to use a catalog part. However, production lead time should be on par with a catalog part due to the use of preferred materials. And one other point to stress is that while initial development time for the custom part may be longer than expected, having a part that fits your requirements nearly perfectly can save development time in other areas as compared to spending time to make a catalog part fit. Still, the overall development time will always be longer for a custom part, so we'll have to say this stereotype is at least partially upheld. Lastly, we note that no tooling costs were needed for this version. In fact, it's fairly rare to need tooling for custom magnetics, so we'll call this stereotype busted. But wait, there's more! Due to the addition of the winding split and the change to the stranding on the primary winding, we were able to realize a 5% higher efficiency for the custom part over the catalog part. Throughout this presentation, several times I've mentioned the importance of finding the right custom magnetic supplier. But how do you know which suppliers will be a good partner? Here's a list of guidelines that help indicate which suppliers will have the resources to add value to your design by designing that perfect custom part. First and foremost, the supplier should have a great team of design engineers, each with their own area of special expertise. And more importantly, those engineers should be available to consult with you as needed. Second, a good partner will have a reliable way to produce samples. But it's not just the ability to produce samples that's important. And qualifying the perfect golden samples during your development phase, only to have the factory fail to reproduce the samples in production, will lead to extra headaches during your product launch. And if and when an issue occurs, your magnetic supplier should have the resources and know-how to help you troubleshoot and solve the problem. The only way you'll get all of this is to choose a supplier that makes custom magnetics a core part of their business, not one that treats it as an inconvenient afterthought. Magnetic components are subjected to more stringent and unique requirements than almost any other component in your design. This means that the compromises to make off-the-shelf parts work optimally are sometimes unacceptable. Some designers are surprised to learn that the cost of a custom component is often competitive with catalog parts, and in some cases even lower. Additionally, many magnetic components only require mild customization to be optimized for your application, eliminating tooling costs and minimizing the impact on lead time. For these reasons, I encourage all users of magnetics to consider the benefits of using custom components in their application. The ability to exactly specify your magnetics is a powerful design tool that can help ensure your project's success.
Whether you're working on a power supply or a specialized industrial application, finding the right transformer can be a complex and time-consuming process, but you don't have to go it alone. We understand that finding this magical transformer can be a bit of a daunting task, so make sure you leave the work to the experts. Contact the transformer design experts at Würth Elektronik, who have decades of experience and commitment to the trade. You can find more information online and get in touch with the team by visiting our website at www.we-online.com. And while you're there, you can complete your design with EMC components, connector and assembly parts, optoelectronics, and so much more. You're listening to Würth Elektronik's What's Up radio podcast, where each week we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronik technical specialists who are going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast.